So last section we're going to take a look at for this week is 1.2 and part of 1.3. So we'll be leaving off in the middle of 1.3 and we'll be finishing that next time. So the first thing they mentioned in 1.2 is this general problem solving process. It's not really anything specific to math necessarily. It's just kind of like how you could go about thinking about any kind of problem that you have to solve. But we'll talk about some specific problem solving strategies in this that do apply to math. So first thing we want to make sure we do is read the problem and understand two main things. What are they giving me and what are they asking me to find? If you don't understand what they're giving you for information, you're not going to be able to use it to find what they want you to find. And the next thing is to think about what problem-solving approach might be best, right? So sometimes drawing a picture, especially for a word problem, that's a big one. Draw a picture, sketch a diagram. Anybody think of another approach you might take to solve a problem besides making a sketch? What else might you need to make sometimes in order to solve a problem? Yeah, Caleb?
Maybe just like rewriting the problem.
Okay, you might want to rewrite the problem, especially like in Algebra 1. I teach, something like 12 is what percent of 50? So I teach them, let's change it step by step. 12 is means equals, of means multiply, percent of 50. So you're rewriting something that was more as an English sentence into something that's more of an equation. So creating an equation to solve from what was given, that's almost involved in every word problem. You have to create some kind of equation. What else do we have? So making a list. Sometimes if I gave you a problem like taking the letters A, B, C, tell me all the different ways you can arrange them. ABC, ACB, BCA, CAB, all that. Okay, so sometimes making a list is helpful, but sometimes that can also be a little lengthy. So it depends on what you're trying to do. Okay, but if it's short enough, maybe making a list would be helpful. And page 13 in your book gives you some kind of general guidelines. But pretty much anytime we've got a word problem, we're going to have to create an equation out of it. And sometimes we're going to have to make a sketch. Especially when we get to trigonometry, sketches are going to be very helpful. And looking for a triangle within the sketch. So then, once you've figured out what they're asking you to do, information you've given, and you've decided on an approach you're going to take to solve the problem, now you actually want to go ahead and do that. Right? So if you decided you're going to make an equation, all right, now you want to start translating the words into symbols or numbers or whatever you have to do to make your equation. So we'll look at an example and see if we can figure it out. So this problem, I just kind of wrote down the important thing from the book. It has to do with a company renting a car, and they charge you $15 to rent a car, plus 20 cents for every mile you drive. And they even tell us what variables to use. There's going to be two variables involved. Okay? One has to do with the cost that you pay, and the other one has to do with the number of miles you drive. Which variable is the independent variable there? Yep, Nick?
X.
Yes, X is always your independent variable because the cost that you pay depends on how much you drive. So in this particular example, the cost is dependent on how far you drive. So cost is dependent, X is independent. Another name for that, X is your domain, Y is your range. So it says, write an equation to model the following situation. So we're going to write an equation which is going to model the situation, and then I'll give you some examples where we're going to plug some numbers into our formula. All right, so if we're going to write an equation basically that you could use to calculate your cost, what should your equation start with? Yep, John?
Y equals?
It's going to start with y equals. Now, on the other side, we've got to take into account those two things. Anyone think they can give me an equation that would take into account $15 to rent the car plus the 20 cents per mile? Madison?
15 plus 0.20x.
Yeah, and I'm just going to use the commutative property and write it in that order. Anybody know why I wrote 0.20x plus 15 instead of 15 plus 0.20x? They're both right. Yeah.
Because y equals mx plus b.
Yeah, we're already in y equals mx plus b, so if we're going to be doing any kind of graphing, it's in the standard format we're used to. All right, so there's part one. There's our equation. Now, it says to use that model to predict the cost for 50 miles. So we want to make sure we put the 50 in the right spot. Sophie, what letter is the 50 going to get plugged in for?
X.
X. Okay, X is your miles. Y equals 0.20 times 50 plus 15. So what's that going to give me? 0.2, that's 1/5. 1/5 of 50 is 10 plus 15 is 25. And usually in a word problem, you have got some kind of label. What's the answer there? $25. We're talking about dollars. So that's $25. Now, to drive 100 miles, can I just say, oh, double the miles, double the cost, $50? Why not?
Because you don't add an extra $15.
Right, good. You don't add that 15. That 15 is a one-time fee. Okay, so it's not, you might think that makes sense, double the miles, double the cost. No, it's not, it doesn't work out that way. So 0.20 times 100 plus 15. So what's it going to cost me in that case to rent the car? Yep, Tim.
$40.
Let's see. Can you walk me through how you did that?
Well, 1/5 of 100. Oh, I'm done. It's 35.
35. So yeah, we'll multiply by 100. In this case, we can just move the decimal 2 places. 20 plus 15. That's going to give me 35. Good. You figured out what you did wrong, so that's good. All right. Any questions on that? All right. So 0.20x plus 15 is what we call the algebraic representation of the problem. Right? Somebody could walk in here right now and look at this equation, and they have no idea that it's about renting a car and you pay 20 cents a mile and you pay $15 up front. Okay. The equation basically is more abstract. Gets rid of kind of the content of the word problem and just turns it into a purely mathematical equation. So if you ever see directions asking for an algebraic representation of the problem, basically it means make an equation. All right. So now, using that same example, suppose that Sarah was charged $50 as the final cost for renting the car. How many miles did she drive? This is a little different. How would I go about figuring that one out? Sophie?
You can put 50 in for the y, it's all for x.
Exactly. We're going to plug 50 in for the y. So what we did before was arithmetic. We already had a variable by itself. We just have to do some calculations. Now what we're doing is algebra. The variable is not going to be by itself. So 50 equals 0.20x plus 15. Actually, I think So this is the way Sophie said to do it. She said plug in 50 for y, and then solve for x. Okay, that's an algebraic approach. So we'll do it that way first. So subtract 15, that's going to give me 35. Again, 0.2, I know that that's a fifth. So that's like having 1/5 x on this side. So if I multiply both sides by 5, that'll give me x by itself. So 35 times 5 is 175. And what is that? 175 miles. Good. Very kind of simple two-step algebraic equation. Any question on that? All right, so that's an algebraic approach. Let's look at more of a graphical approach. So I'm going to show you something on the calculator. I'm going to go back to this. Let's pretend that this was something you were going to graph, and this was something else you were going to graph. So if you create two graphs and you want to know where they're equal, what do you think that means visually? If you have two graphs and you want to know where they're equal, that's kind of a weird way to say it, but it really means where the graphs do what? Yeah?
You have a point at 50 and then like the slope of 0.20x, like it's in somewhere. And like you see where they intersect.
Exactly. We want to see where they cross. Yeah, we want to see where the two graphs cross. So the calculator can do that for us. So let's type in each of these graphs. We're going to type what's on the left as one graph. We're going to put what's on the right as another graph. So first thing we're going to do is we're going to turn it on. If there's anything on the screen here, you can hit clear. If you go to y equals, and you have something typed in from yesterday, you can clear that too. So we're starting on a screen like this. So we can type in lots of different graphs. We only need to type in 2. Technically, you can use any 2. I'm going to do the first 2. I'm going to put 50 for one of my graphs. And then I'm going to graph down below, hit the down arrow, 0.20. And remember, x is right below the mode button, plus 15. Anyone have trouble typing that in? Yes?
So is it going to be different if you would hit alpha and then the STO arrow button, which has an X? Is it going to give you a different answer?
I think it should be the same thing.
Okay.
Yeah, it should be the same thing. Now, I'm going to press, before I graph, I always like to start, with the same window for everybody. So I'm going to press zoom. I'm going to press 6. And when you see that little circle in the upper right stop spinning yellow, then you know it's done. So what happened here? Yeah.
You gotta adjust the window.
I got to adjust the window. It's off the screen. Think about what you just typed in for this first one. Y equals 50. What does that look like? When you have y equals a number, what does the graph of that look like? Yep. So, yeah.
It's a horizontal line.
It's a horizontal line at what number?
50.
50. We're nowhere near 50. All we're doing is we're looking from negative 10 to positive 10 on the x and negative 10 to positive 10 on the y. So we need to look higher. In fact, we probably want to go even higher than 50 because we're going to be looking for where a horizontal line and then a line on an angle is going to come up and hit it. So I don't like to have the line right on the edge of the screen. So let's do 60. And leave me a little bit of room above it. And now let's hit graph and see what happens. Okay, so there's our line at y equals 50. But the problem is where they cross is still off the screen. So there's only one value I need to adjust to fix that. Is it the x min, the x max, the y min, or the y max? Think about, yeah, Julie?
Is it the X max?
It's the x max. In fact, we already know what the x max has to be. We're only looking to 10. We already know the answer is 175. Normally, we wouldn't know that. So we just have to take a guess and set the x max bigger. And we could try 200. That we know it's more than what we need, but that'll be fine. We're looking to find what's called a complete graph, which will show exactly where they cross. Now, if you did 250, if you did 300 for the x max, any of those would be fine. What I probably wouldn't do is like 2 million. If you do 2 million, it's going to squish that graph so much you're not even going to see it. All right. So now, I think Nick had said it earlier, we want to see where they cross. Well, the calculator can do that automatically. There is this button trace. And before they had this other button I'm about to show you, all you could do was kind of go over there using trace and try to see, all right, it looks like it's around 176, and I could zoom in and try to get it more and more accurate. But now there's a button on the calculator that will find the intersection automatic for you. Anytime you want to calculate something having to do with graphs on the screen, you're going to use the calculate button. It's right above trace. So you want to press second, trace, and you should see this screen. We won't use options 6 and 7 pretty much all year. We never will. Those are for calculus. But the other ones we will use. Which one do you think we're going to use to see where the graphs cross? Yeah, Madison?
5 and
Yeah, so we're going to press 5, which is intersect. Now it's going to ask you some questions. It's going to ask you 3 questions. It's going to say, what's the first? Because you could have lots of graphs on the screen. You could have a blue one, a red one, a green one, a yellow one. But you can only find where 2 cross at a time. We only have 2. So it's going to ask you, what's the first line on the screen that you want to use? Okay. And I'm on the blue one, so I'm going to hit enter. So it's going to find where the blue one, and now I have to pick the other line that I want it to find where it crosses. It automatically went to the red one. So I'm going to hit enter on the red one. If it didn't go to the red one, and I hit enter again, that's like trying to find where the blue line crosses itself. You can't do that. You have to pick 2 different graphs to see where they cross. So blue, I'm going to press the down arrow, and now I'm on the red. It doesn't matter where on the red I pick it. It's just somewhere on the red, so the calculator knows you want the red. Now the guess. In this case, the guess is not important. It doesn't matter at all. The guess only becomes important if you had something like this. In this case, there are 2 intersection points. The calculator will only give you 1 at a time. Wherever you put a guess, it's going to give you the intersection closest to your guess. Since we only have 1, I can put the guess right there. I could put the guess over here. It doesn't really matter. It's going to find the only intersection point, which is right up there. If you want to take the time to put your guess over there, you can do that too. It doesn't matter. But you hit enter for a 3rd time. And you should get something like that. It says intersection at 175. Okay. Anybody not get that intersection?
Wait, what did you just click?
For which step? The whole thing?
Just to get the intersection.
The intersection? Once it's on the part that says yes, I just hit enter.
How do you get to the guess?
So that comes up. Does it say first curve, second curve?
Where?
Once you did second calc intersect, and now it says first curve, right?
Yeah.
And now you hit enter once, and then it says second curve, and you hit enter again, and then it has a guess, and then you can enter a third time. So where the first curve, second curve would be more important is if I had something like this. Just type in that. So now I've got a few different intersection points I could find. Let's say I wanted to find where the blue and the black cross. I would have to do second calc, intersect, pick a point somewhere on the blue, which it already is. And now it's jumping to the red one. I don't want the red one. I said I wanted the black one. So I'm going to hit down, and now I can tell it's on the black one. It's blinking on the black one. And I'm going to hit enter. So it's ignoring the red one in this problem completely. And since the blue and the black only intersect in one spot, you can hit enter, and it'll automatically find it right there. Okay, the guess is only important when you have more than one intersection point for the same two graphs. All right. So that was the graphical approach, which I ended up just doing that there. Any question on that? And if you forget, you can always go online, look at the video, and you can see exactly the buttons, or hear me talking about the buttons I was pressing. And I think as I press them, it kind of highlights, makes a little circle when I press it. So if you watch the video, you can see the buttons that I pressed. So when you have a viewing rectangle that shows everything that's important, that's called a complete graph. This is the kind of direction in the homework that you do not have to sketch anything. Find a complete graph of the following problem. All you have to do when it asks you to find a complete graph is tell me the window that you used. So if the last problem said find a complete graph, I would literally just write down these four numbers: x-min, x-max, y-min, y-max. You're writing down the window. I'll probably skip this because we did this exact problem yesterday. But it says graph y equals x squared plus 10 and find a complete graph. So remember, it was shifted off the screen and we had to set the y max. I think we had to reset it at 20 and then we could see it. Anyone want me to go through that exact problem again? Okay. So, don't think I wrote this yesterday, but I mentioned it. When you draw the graph, it's going to end up looking like this. It's 10 units up, and it has that U shape. The reason it's 10 units up is because of that. That's a vertical shift up 10 units. That is called a parabola. Anything you graph where the highest exponent is a 2, that is a parabola. And that's the general form for a parabola. Ax squared plus bx plus c. You see that a lot when you're doing factoring, solving quadratic equations and stuff like that. Parabola would be one of the first graph types that we study later in chapter 1. We study probably about 8 or 9 different types of graphs. And with each graph we study, we talk about how to transform it, how to shift it up, down, left, right, how to stretch it, things like that. You've already seen how to shift something up. It's when you add a number on the end of the function. If you add a number inside the function, that would do something different. It would shift it 10 units, but that would be a horizontal movement. So we'll talk a lot about that. All right, let's find a complete graph for this one. But before we even touch the calculator, what do we know about that function, the square root function? Anybody tell me anything about square roots? Yep, John?
The other
imaginary sums, or like the result is always going to be lesser than the sum of the two numbers in there?
So when you take a square root, it's always less than the thing you started with?
Yeah.
How about the square root of a fourth?
Oh.
Actually, it's bigger. Square root of 1/4 is 1/2. But for numbers bigger than 1, yes, when you take the square root, it does get smaller. For numbers between 0 and 1, it actually gets bigger. We'll study a lot more about that later on, but what else about square roots? Yep.
You could have two different answers.
You can have two different answers. Depends if you're talking, we're talking about what's called the principal root, which means just the positive answer, or we're also talking about the negative, like we had in the distance problem for homework. What about this? It's called the radicand. When you take a square root, that radicand has to obey certain rules. Anyone remember what has to happen with that? Yeah?
Well, it can't be a negative number.
It can't be a negative number. I like the way she said that. She didn't say it had to be positive, because that's not true. It can be 0, and 0 is not positive. So it cannot be a negative number. We're talking about reals. And we talked about that yesterday. We're not doing imaginaries. So we know that x plus 20 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 20. That gives us a hint at setting the calculator up. We shouldn't look at any values below negative 20. They won't exist. Undefined. But we should be looking from negative 20 up. All right, so let's take a look. So I'm going to press y equals. I'm going to clear anything else I have in there. And how do I get to the square root button on the calculator? Go, Tim.
Press the second button, then you press the square button.
Yep. So second, and then the x squared button is the fifth one down on the left. And I'm going to type in x plus 20, and it should all be under the root just like that. Now that's the easy part. All we've done is type the problem in. Now we've got to set the window. Now, unless I would have put a plus or minus symbol in front of that, it's not going to give me both answers. That's only going to give me the positive answer. So what that means is on the y-axis, as far as looking at negative numbers, I really don't need to. I'll leave it, but it's not necessary. Now, what did we say about our x values? What's the lowest that they can go? Yep. Negative 20. So I like to just go a little bit past it. I don't like the restriction to be right on the edge of the screen. I like to have a little bit of space. Now, x max. How high of a number can you plug in and take the square root of? What's the biggest number you can take the square root of? There is no limit. So as far as x max, there really is no limit. You have to set x max high enough that you can at least see what the graph is going to look like. Let's set it up to 200. Now think about that a little bit. If we set it to 200, and you plug in 200, you're going to have 200 plus 20. And you're going to take the square root, and that's your y value. Well, that's about 15 or so. 15 squared is 225. So we got to think about what we're going to plug in for an x value, and how is that going to affect my range. Right? So I would set your y max. 60 is too high. I would probably say around 15 or so. Technically, you could set y min at 0, because you don't need to see anything negative. And let's hit graph. And we get a graph of a square root. It's actually half of a parabola, sideways. That's what a square root function is. If I had put the negative in, you would have gotten the other half on the bottom. All right, and there's nothing else to see here. It's not like all of a sudden the graph is gonna like curve off the screen. No, it's just gonna keep going. Just keep going to the right. So for a complete window, what you would want to write down on this one would be what I have right there. That was a negative 30 to 200. And this. Don't worry about writing the X scale or any of that. We don't need that. That's how you write down your window. Any questions on that? All right, so I think this is the last thing in this part, and then we'll look at the last thing for the other part. You can use the calculator basically to do what's called a scatter plot. You can put in individual coordinates, and I'm going to show you guys how to do that. So we're going to graph these points on the calculator. Now, graphing individual points is different than graphing a line. So what I'm going to do is I went to my y equals, I'm going to clear it, so I get rid of that. And I'm just going to leave it on that screen. So to graph these points, the first thing we have to do is type them in. To type them in, the first thing you're going to want to do is press the stat button. Okay, the stat button is in the third column, second button down from the top. It's right below delete. And what we're going to want to do is edit our list of numbers. So it says go to edit. So we're going to hit enter. They give you lots of lists of numbers here. L1, L2, L3. We only need two lists. One list is going to be X values. The other one is going to be Y values. Anybody that didn't get an L1 or L2 on their screen?
Zach, what'd you press again? You pressed
Stat, and then go to edit. It should be the first option once you press stat. Is that a TI?
It's TIA 4 plus.
That's the same one that I have. Yeah, that's the same one I have.
So,
You press. What do you get when you press stat?
well, first when I press stat, that happens, and then.
No, not stat plot. Stat. Stat.
Oh, stat.
Yes.
Oh, yeah.
Yeah, stat plot is different.
Yeah, about that. Yeah, that makes a lot of sense.
Okay. Anyone else not at that list? All right. So now we're going to type. You don't have to do it this way, but it is the easiest. We're going to type the X values in L1, and we're going to put the Y values in L2. Okay, so the way you type them in, the X values start at -3 and they go to +3. -3, and you hit enter each time. It's easy to do all the X's first because when you hit enter, it goes down the column. -1, 0, 1, 2. Now, if you make a mistake, let's say I accidentally put in the wrong number, you can always hit the up arrow, and you can press delete, and then you can do it again. So we should have -3 to +3 in L1. Now to get to L2, that's where we're going to put the Y values. Press the right arrow, and it'll go over to L2. And now type in the values on the board in the bottom row. -18, -2, 2, 0, -2, 2, and 18. Okay, everybody have that? All right, now you don't have to save it, it's automatically saved. We're just going to quit. All those numbers are still there. and it says go to the y equals. That's the button we normally hit when we're going to do a graph. But now we want to turn on one of the plots. We're not graphing an equation, we're graphing points. So we're going to turn on, doesn't matter which one you turn on, but let's turn on the first one. Okay, to turn it on, your cursor should be blinking in the row that says y1 equals. You're going to press up. If you press up, now plot 1 should be blinking. Anyone that doesn't have plot 1 blinking? Now to turn it on, hit enter. Now if you press the down arrow and move away from it, it should be highlighted because now it's been turned on. Anyone that doesn't have plot 1 turned on. So we've typed in the points we want to graph, we've turned on the plot. Now, just like any other graph, we need to set the window. That's not a good window for this scatter plot. What was my smallest x value? -3. And how about my largest? 3. Let's go -5 to 5. Again, just so it's not right on the edge of the screen. What was my smallest y value? -18. So what do you think a good y min would be? Mike?
-20.
Yeah, we'll go -20, and let's go +20. And now we're ready to hit graph. So once you set your window, if you press graph, you should see points that look just like that. And the next thing we can do, which I'm not going to get into this part, but I'm just going to show you something. I'm going to go stat, calc, cubic. Again, don't worry about what I'm doing. I just want you to see something. Calculate. And now I'm going to go y equals, and I'm going to graph something. Bars, statistics, equation, regex. Now, watch what happens when I hit graph. What I did is I used the calculator to calculate an equation that would go exactly through the points we just put in the calculator. So if you were doing the lab or you had some data and you plugged in your data points, your calculator can find an equation that fits your data points for you. That's the real use of doing something like that. But I just wanted to show you guys how to put in data points. Now, what we're going to do is we're going to clear those lists. Now, let me see if I can clear it in one button. I've never tried this, so let me try. Let's take list 3, because that's blank. And let's store that in list 1. And, oh, I can't do it that way. All right, so what we can do, I'll have to look up how to, let's see if I store 0 in list 1. See if that wipes it out. No, it won't let me do that. So, one way you can get rid of the numbers in your list is if you go back. Oh, it did get rid of it. But it said it did. I don't know which one got rid of it. Let me try this. Let's take list 3 and let's store that in list 2. All right, it says invalid dimension, but let me see if it actually did it. Huh, it did do it. Okay, so I want you guys to type that in, and then it'll get rid of all the numbers in the list. The way I typed it in, I had to type it in twice. List 3 is blank, so I'm just using that to copy it into the other 2 lists to make it blank. So you press second and the 3, and that's how you get the variable for list 3. Press the store button, and we're going to store it in press second 1, and then hit enter. You're going to get an error. It seems to still work though. Just press quit. And then type in the same thing again. Second, 3, press the store button, and store second 2. So you should type those 2 commands on your screen. I know it says error, but now once you guys go back to stat and you go to edit, are all your numbers gone? Yep.
Where's the store button?
The store button is right above on. Yeah, right above on. Second button up on the left. Did that wipe everything out? Okay, I don't know why it said error, but it worked, so we'll go with that for now. Yes?
Is just using the clear list command under stat do the same thing?
Stat
At the bottom clear list, there's that.
clear list. Oh, perfect. So you could just do clear list and then probably do L1. I wonder, could you do comma L2 and do both at the same time? I wonder if that works. Yeah, probably would have worked. That's even better. I'll use that in my next class. Thank you. This, I'm not going to get into. I already showed you that. That's the equation that I graphed. And I wanted to show you that you can use the calculator to find a graph that fits your data points. Sometimes it's not exact, but I picked points in this case that it was perfect. Those were perfect points that fit on this graph. All right, so last thing we're going to look at, I'm not going to do very much with this, is part 1 of section 1.3, which is on functions. Some of this I already mentioned as we use some of these terms, input, output, domain, range. But when we did that rent-a-car example, X has a few different names. It's known as the input, the domain, or the independent variable. Y is always your output. Your range, or your dependent variable. So just different terms we might use to represent the X and the Y variable. Now, does anybody remember what makes a graph a function? Some people think of it visually. It has to pass a certain test. We're going to talk about the test later on. Yep.
The vertical line test?
It has to pass the vertical line test, which if something passes the vertical line test, basically means that every input has one output. And you plug in a number for X, and you're guaranteed to only get one answer for Y. This is not a function. Because if you plug in a number for X, I can give you 2 answers for Y. If you tell me X is 16, I would say Y is 4 or negative 4. Not a function. So a function is where you plug in one number for X, you get exactly one answer for Y. Not going to worry about this. Kind of already said this in another way earlier, but the domain is your input, range is your output. I'm just saying it again. Valid means you can plug it in. Negative 10 is not a valid input. Negative 12 is not a valid input. Negative 1 is a valid input. You can do that. But valid means you're allowed to plug it in. Already said to you that earlier, we're dealing with real numbers in chapter 1. We're not dealing with imaginaries. 2 different notations you can use to write a function. We've been using this y equals notation, but does anyone remember how you pronounce that? That's used quite a bit. Annalise?
Is it f of x?
F of x. Yep. So we might, and you can use different letters there. You can have g of x, f of x, h of x. It's just a different notation for writing a function. It's f of x notation. Yeah, I'm going to skip that one because we already did a square root problem where we had to find a complete graph. I think we did x plus 20. This is almost the same exact thing. But what I do want to do is just see if we can find the domain and the range. So domain is what you're allowed to plug in. What did we say about x minus 3? We have to make sure that what? Yep. It cannot be negative, which means it has to be greater than or equal to 0. Well, that tells you your domain if you solve that equation for x. The only two things you have to be careful about with domain is you never want to plug in a number that would cause you to take the square root of a negative, and you never want to divide by 0. There's no fraction in this problem at all, so dividing by 0 is not even a thing in this problem. So what does that mean my domain would have to be? Yep.
X is greater than or equal to 3.
Yep, x is greater than or equal to 3. Or to use a little bit of the notation we learned yesterday, you can pick any number from 3. Bracket means you can include the number up to infinity. That's another way to write it. We always use a parenthesis on infinity because you can never reach infinity. So you can't go and reach it. So it's a parenthesis. Bracket means greater than or equal to. That's my low value. And infinity is my high value. It never stops. Right? And the graph, just to show you how it would look, would be something like that. So the graph is never going to go below 0. But how high is that curve going to go? If we just kept zooming out. Yeah. It's still going to just keep going up. It curves up slowly, but it does keep going up. So my range is how high and low does the graph go? Well, it doesn't go any lower than 0. And it goes up forever. So domain is left and right. Range is up and down. Question on it? Okay. That one. Yeah, let's get that. So when they ask you to do something like this, find f of -2, find f of 3, find f of a. All that it means is to take whatever value they give you and plug it in and evaluate. Could be a numerical answer, could be algebraic, depends. So if I wanted to find f of -2, how about Maddie, what number am I plugging in? Anyone help her out? If we want to find f of -2, what number do they want me to plug in for x?
Oh, would it be -2?
Yeah, we just want to plug in the -2. So just plug in the given value and then evaluate. So f of -2 would be, always use parentheses when you plug in, just in case you have a negative, +1. That's it. That's what it means to evaluate. They said to plug in 3. Plug in 3. They said to plug in A. Plug in A. There's nothing you can do there. Any question on that? So, I think this is the last. That's the last one. Actually, I showed you that earlier. I said to you that earlier that a square root is not a function. And I asked, there's a special test that you can use to tell if something is a function. Was it Nick? Did you mention, what was it called again?
Vertical line test.
Yeah, the vertical line test. So the vertical line test is used to tell if something is a function. It's a very simple test. If you have a graph and you take a vertical line and you place it on your graph, if the vertical line, when you move it, can hit the graph more than once, like in that case, your graph is not a function. And that's it. So if a vertical line hits the graph more than once, it's not a function. That's why the square root one is not a function. That would be the top part. That would be the bottom part, the side of this parabola. All right, so normally today we would have had a test. So we've gone over the homework, had a test, and that'd be it. Obviously today we did not have a test. So I'm going to give you guys something to do. It's not going to be turned in until we have until September 7th to do it. Okay, remember Monday the 6th, that is Labor Day. Okay, so if you want to write it down, page 20 is the first part of what we did, page 30 is the second part. You can write it. If you want to just wait and check it on YouTube, I'll put it up on YouTube in about 15 minutes.
I can take a photo of this.
Yeah, I'd rather you either write it or if you want to go online and get it. It's also on Schoology too.
Well, I mean, could I just take a photo of, like, oh.
Yeah, I'd rather I try to limit like how many photos during class. I let the diagram someone do it because that diagram was not on Schoology or YouTube. But this is on Schoology, this is on YouTube. So it'll be in a couple different places. Is anybody having trouble accessing the book online? Okay, if you are and you need a physical copy, just let me know.